Right, we're going to have a little look at trigonometry in this video. Trigonometry sometimes sounds a little bit daunting to some people, but actually once you get to know it, it's quite enjoyable. Right, okay, what's it looking at? It's looking at finding the missing lengths or missing angles in right-angled triangles in this particular video. It does go beyond this, but this particular video is just going to be looking at dealing with right-angled triangles. Okay, so if you've done a bit of Pythagoras, some of these words that are on here you'll be familiar with, for example, the hypotenuse. Opposite and adjacent, perhaps you won't be familiar with just yet, but we'll be looking at those in a second. Okay, so hypotenuse. Let's look at this triangle. One thing that I've noticed on this triangle is that we've highlighted this particular angle here, down at the bottom right. All right, so that affects labelling up the triangle. The hypotenuse is always going to be the longest side, all right? But these two, opposite and adjacent, will change depending on where this angle that we're trying to find out is, okay? So in this particular case, the adjacent is going to be this side. Adjacent means next to. So this line here is next to the angle, all right? And that means that this side is going to be the opposite, because it's opposite the angle. Okay, the angle is almost looking at that, so that's why that's the opposite. In this particular triangle, you can see the angle has changed places. The angle that we're looking for is over here in the top left. So, longest side is going to still be the hypotenuse, so that's going to be there. Remember also, the best way to find the longest side is that it's opposite the right angle. So the hypotenuse is going to be in exactly the same place, but the adjacent is now over here because it's next to the angle. The angle has moved, which means the opposite is going to be down here. All right, so familiarise yourself with those terms, those names, and where to label up the triangle. Calculator, all right, so specifically for trigonometry, we're going to be interested in these three buttons here. Sin is short for sine, cos is short for cosine, and tan is short for tangent. Also, above these buttons, you'll see sine to the power -1, etc., with cos there and tan there. We'll also be using those as well. And to get to those functions, you're going to be using your shift button. Okay, on some calculators, that shift button is known as the inverse button, or inverse shift second function. All right, so just use that one and these three. Also, on some occasions you might be able to use your SD button. If your answer comes out and it's in surd form or a fractional form, use the SD button just to change it into a decimal value. Right, now these are the trigonometry ratios. These triangles here are very similar to compound measure triangles when you're looking at speed, distance, time, etc. like that. And they work in the same way. You won't be given these in the exam, so you need to learn them. All right. So, ka, tawa is a very common way that these triangles are explained, or a way of remembering them. I use a little rhyme that actually my old maths teacher taught me, which is smiles of happiness come after having tankards of ale. Now, I'm not promoting drinking or anything, but it's just a rhyme, and it's worked. It's stuck in my head for all these years. So you can make your own one up, or you can use Sokotoa or something similar to what I've just used. But do remember, they won't give you these in the exam. Right, okay, let's start applying some trigonometry rules to work out missing sides of triangles to start off with. Okay, so first thing I need to do is I need to look at this triangle, and I need to look to see what I've got, what I've been given, which is this length here, and what I've been asked to find, which is this length here. Okay, so I need to label up the triangle. So what have I got? I've got the side that's next to the angle. So I have the adjacent. I need the side that the angle is looking at. So that's the opposite. So that's going to be that there. Okay, now what I do is I look at these three triangles and I look to see which triangle has got the adjacent and opposite in it. So I'm looking for A and O, and here they are, A and O. They're in this blue triangle, the tangent triangle. They won't appear in any of the others, so I'm going to use that triangle. Now, with these triangles here, I'm going to cover up what I need. Remember, I need the opposite. So I'm going to cover up the opposite. And now this is telling me that I have to do tan. All right, and you see that little angle sign there? Tan is connected to the angle, so I'm going to be using 36. So tan 36. I'm going to times it by the adjacent. Okay, if you're looking across, you're timesing, and if you're looking up and down, you're dividing. So I'm going to times that. So let's just have a look. The adjacent is 8.7. The angle is 36. So what I'm going to do is I'm going to do tan 36. Now if your calculator brings up a bracket to begin with, remember to close the bracket afterwards. Tan 36 times by 8.7, which is the adjacent. All right, 36 goes there, 8.7 goes there. All right, if you type that into your calculator and press equals, you should get an answer of 6.3 centimetres. Now that I'm writing that just to one decimal place. All right, there'll be more numbers on that on your calculator. Okay, so that's that one. Let's have a look at this one. Same method here. All right, what have I got? What do I need? So I've got this long side here that's opposite the right angle, and I need this side here that the angle is looking at. So that tells me that I got the hypotenuse and I need the opposite. So looking at these triangles up here, which one has got O and H in? It's this one here, O and H. And I'm going to cover up what I need. So I need the opposite. So I'm going to cover up the opposite. Very similar to the first one. All right, I'm going to do the sine of the angle, and I'm going to multiply it by the hypotenuse. So that's sine 60. If you calculate, puts a bracket around it, remember to close the bracket. And I'm going to times that by the length of the hypotenuse, which is 32. Just to make sure we understand what we're doing, the 60 has come from the angle, the 32 has come from the hypotenuse. Okay, and that should give you 27.7 centimetres. Again, I'm writing that to one decimal place. This one's taken from an exam, but I need to do exactly the same thing as I did before. I've been given this side here, which is 5 centimetres. They say calculate the length of YZ. So I'm looking for Y, and I'm looking for where that finishes at Z. So they're asking me to calculate this bottom length here. So what have I got? What do I need? Well, this 5 is opposite that angle, so that must be the opposite. This long length down here is opposite the right angle, so it must be the hypotenuse. So I've got opposite over here, hypotenuse down there. Looking at my trigonometry triangles, opposite and hypotenuse, okay, that's here, yellow triangle. So I cover up what I need, and this time I need the hypotenuse. So because we've got values above and below each other, all right, I've got to do divide this time, but I've got to make sure that I divide the right thing by the right thing. So what's on the top? Opposite is on the top. So opposite is what I'm going to do, and I'm going to do opposite divided by the sine of the angle. Okay? So the opposite here is 5 centimetres, and I'm going to divide that by sine 32. This 5 centimetres is coming from there, 32 is coming from there. Alright, and if you do that, that equals 9.4 centimetres, again to 1 decimal place. I'm just looking here, because I've got the hypotenuse, I must make sure that this answer is bigger. Any other side. Okay. In this triangle, slightly different from the others, we've got to find the angle. They're asking us to find the angle. But we're going to use a similar method. We're going to look at what we've got and what we need. So I'm looking at the two lengths here. We've got a side here that's opposite the angle, because the angle's looking at it, and we've got a side here that's next to the angle, but it's not opposite the right angle, so it's not the hypotenuse, so therefore it must be the adjacent. So let's just label up those sides. So this was the opposite, and this is the adjacent. Okay, so let's look into the triangles and see which one has O and A in it, and it's this one at the end, O and A. So we're going to find we want the angle. So this time we've got to cover up tan, because that's where what's attached to the angle. So I'm going to cover up tan, and I'm going to have to follow the rules, and I'm going to have to do the opposite divided by the adjacent. Be careful you get these the right way round, because the opposite is smaller, but we still have to do opposite divided by adjacent. So let's give that a go. So that will be 5 divided by 12.5. Press equals at that point, but you don't need that number. You can just carry on with what we're going to do. And now, because we're finding the angle, we're going to use the shift function, using the shift button that I mentioned at the beginning. So we're going to do shift tan, and we're going to do equals again. And at this point, you get your answer. So to 1 decimal place, you should be getting 21.8 degrees, and it's degrees this time. Okay, so just remember, when you're finding a side, you're just using the normal sine, cosine, or tan buttons. If you're finding an angle, remember to use the shift function here. Okay, and it will be the same if you are finding angles in a cos triangle or sine triangle. Okay, I hope that helps.